In today's video, we're going to be talking about the shape, the center, and the spread of data. So when we're talking about the shape, so the shape tells us how the data is distributed. So the shape tells us how the data is distributed. Is there more data values on the lower end? Are there more data values on the upper end? The center of the data is the middle of the data set, and we normally look at that with our mean or our median. Now the spread of the data, we normally look at this, how spread out our data is, by looking at the range, but there's other options with interquartile range, the mean absolute deviation, or standard deviation. But we're talking about how close together are our data values, or how far apart are they. So again, when we talk about the spread, we're talking about how spread out they are, the range, the maximum minus the minimum. The peak are where the point where the data is higher than the other parts of the data set. We normally look at this with mode. So when we talk about peak, we're talking about which one occurs the most. Now if we have one peak, we call it unimodal. If we have two peaks, we call it bimodal. If we have multi, we have multimodal. And if there's no peaks at all, where everything's the same, then it would be called uniform. Now, looking at the example on this page, it says students were surveyed on how many minutes they spent reading each night. So when I'm looking at this situation, we're looking at a histogram. So remember, histograms are going to give us an interval of values. So in our first little column, we have 0 to 4. So they study from 0 to 4 minutes. So two students study 0 to 4. We don't know if those two students, if one studied 1 minute, or they both studied 2 minutes, or both studied no minutes. But we know that it fell within that 0 to 4 range. So the question is how would we describe the shape of this data? So when I look at the shape of this data, I will be looking at it in the respects of it is very much symmetrical, that my left side is equal to my right side. So we would consider this a symmetrical shape. Okay. How many peaks does it have? So remember, the peak is which one occurs the most. So this column between 15 and 19 are which one occurs the most. So we would say that it had one peak, and remember we called one peak unimodal. The next question says estimate the center. So thinking about the mean or the median. So the center is where we're looking at the middle. So because this is symmetric, now this is not always the case, just because we may have some that are shaped differently, but because this is symmetric, we can say that the mean and the median are going to fall in this range between 15 to 19. So we could say approximately 17. Then they want to know about the spread. Now remember, the spread is how far apart my values are. And again, this is kind of difficult to do with a histogram because we know that our values start at 0 and they go to 34, but that doesn't necessarily mean that we had values, the number of minutes, we had 0 minutes that somebody studied, or we had 34 minutes that somebody studied. But if we would describe the spread, we would say that it was relatively spread out. We have 0 minutes to 30 minutes. So for this particular one, we're just going to make a general statement that the data is relatively spread out. Now, so we're going to put a little bit more emphasis on what our shapes look like. So we've already kind of talked about the symmetric shape. So data sets can be categorized on how they are shaped by 3 possible situations. So in these situations, we talked about the symmetric. That means that we have that bell shape. So the bell shape, if you think about an old-timey bell, it's very evenly shaped or very symmetric on each side. I'm going to try to get mine to look a little bit more symmetric. All right. So we have that bell shaped. We have that really tall section and they go down symmetrical on each side. Same thing with my histogram. My median is very much in the middle and each section is very evenly spaced out. The mean and the median of a symmetric shaped data set are going to be very close to each other. So then we have what we call skewed right and skewed left. Now, skewed right and skewed left are probably the most common mistaken names, I guess you could say. Like, students will recognize what's going on, but they'll give it the wrong name. So when we talk about skewed right means that I have more data on the left, and then it has this long tail on the right hand side. So the data is being skewed away from where everything is normal, where most of my data is. So when I say skewed right, that means that most of my data is sectioned on the left, and then it tails off to the right. Now, if I talk about the same thing for skewed left, the same situation applies, but the opposite. So I have more data on the right, and then it tails off to the left. So you think about the opposite. So if it's skewed right, that means there's less data values on the right. If it's skewed left, then that means there's less data values on the left. Okay? Now, it can be a little bit tricky to determine skewed right or skewed left sometimes with histograms. So the way that I look at it is I think about it in terms of my upper section and my lower section of my histogram. And I think about how spread out. Now remember, in a histogram, each section is worth 25%. So if I look at the upper section from the median to my maximum, it ranges by 20, because 30 minus 10 will be 20. Then if I look at my lower section, I know that this one is 10 to 0, so that's ranging by 10. So I know that we're looking at more values are chunked in this 10 section. This one is less spread out, so there's more here. And then this one is more spread out on this side, so that means that this longer section is the tail. So therefore, that area is where most of the data is, and then it's going to have the tail on the section that's more spread out. So this is skewed to the right because there's a longer section on the right from the median. All right, so if I do the same thing with skewed left, so I'm going to start with the lower half. So the lower half from the median is 20, so that's a spread of 20. And then the upper half is a spread of 10. So there's more that are going to be grouped in that 10 range, because there's 50% in that section, and it's in a small section. And then the tail is going to be the one that's more spread out, which is that 20% range. So the tail is actually going to be on the left side this time. Okay? Now, let's do some comparison just so we can kind of look at it a little bit more and hopefully understand this skewed left and skewed right. Alright, so it says people were asked if they own cats or dogs. The data is organized into 2 histograms below. Now, the first thing I do when I look at histograms is I really like to go ahead and figure out how many total of each I have in my histogram. So I'm comparing how many cats these owners have. So how many owners are we talking about? So I'm going to add up my columns. So I have 1, I have 2 here, 3, 4, and 2. So if I add these up, I've got, so 1 and 2, that's 3, 6. So this one has a total of 12 owners. All right, and then over here, I have 2, 3, 4, 3, and 2. So for this one, I have 2, and that's 5, 9, 12, and this one is 14 owners. So when I'm comparing these, I just like to know the totals, because you never know when they're going to ask about potentially the median or the shape or whatever it may be. So it says, what is the shape of the cat owner of the histogram? So cat owners, they want to know about the shape. So if I'm looking at this shape, I can see that there are more values that are kind of grouped in this 4 to 5 and 6 to 7 range. So it's not symmetrical. So I have my tail, which are my lower values on the left, and then I have more values on the right. So if I have the tail is right here, is on the left, that means it's going to be skewed left. Okay. So then it says, what is the shape of the dog runner? So I can clearly see right here that this is very symmetrical. So that's got that bell shape. So if it's symmetrical, that's the shape that we have is symmetrical. So it's symmetric. Then it says, how do the spreads of the two data sets compare? So again, this is a little bit harder to say for sure because if you look at the last part, it says 8 plus. But I have a total of 12 owners in one and 14 others in the and 14 owners in the other. But I could have, out of my cat owners, I could have a cat owner that owns 12. It says 8 plus. I could have another dog owner that owns 15. We just don't know because of the fact that it's an interval. So it should be even here, but even though it says the spread, we're just going to say that they relatively have the same spread. We can't guarantee that it does because it's a histogram, but we will look at some box plots in a second that do show some of the where you can calculate the actual spread. So the only thing I can really say here is they have about the same spread. I don't want to assume too much. How do their peaks compare? So peaks, remember peaks are their modes, which one occurs the most. So if we're looking at our intervals, my intervals both have one peak that occurs at 4, and one occurs from 6 to 7 for the cat owners, and the other one has a peak between 4 and 5 dogs, but they both are unimodal. All right, so let's take a look at some more histograms. So it says, for 1 through 6, a group of 10th to 12th graders are surveyed about how many t-shirts they own. So we have 10th graders and we have 12th graders. Which set of data is symmetric? So if I look at my two sets of data, which one is symmetric? And I would definitely say the 10th graders are symmetric. And it says, give a reason for the difference in their shapes. So why would these be different in their shapes? So I would say that the 12th graders are skewed to the left because there's a tail on the left. So why would 12th graders have the option to own more t-shirts? Well, they would have more time. A 12th grader would have 2 more extra years of high school to gather more t-shirts. So 12th graders had more time to collect those t-shirts. Then it says, how do the medians compare? So the medians, remember medians is the middle value. So I'm going to actually look at how many total 10th graders are and how many total 12th graders are. And then I'm going to kind of look at where that middle number would fall. So here I have 2, 3, 4, 3, and 2. So we have 5, 9, 12, 13. So we have 14 10th graders. Then we have 1, 2, 3, 4, and 3. So if we add these up, we have 13 here. We have 13 12th graders. Okay, so if I'm thinking about the median here, so 14 divided by 2 would be 7. So because it's even, it would fall between 7 and 8. Okay, so I'm going to count up until I get between 7 and 8. So I have, I'm going to kind of use a pink here. So I have 1, 2, 3, 4, 5, 6, 7, 8. So it falls in this 10 to 14 range for the median. All right, so now I'm looking at the 12th grader. So I have 13. So 13 divided by 2 is going to be 6.5. So we would fall between 6 and 7 as our median. So again, I'm going to count them and see where that 6 to 7 falls. So I have 1, 2, 3, 4, 5, 6. And it's going to fall between that 6.5 to 7. So we're in that 15, right on the border of that 15 to 19. So it says which one has a greater median. So if I'm following the 10 to 14 and this one's in the 15 to 19 range, then the 12th graders have a greater median. All right, how do the spreads of the data sets compare? So the spread is going to be my range. Again, I can't really determine the range because of the intervals. I don't know if one starts at 20 or 24, but I can say that they do start at 0 and 24. So we're going to say about the same again. We'll do a better comparison of spread in just a second. Then it says, what is the shape of my 12th graders? Well, we said the tail was on the left, so this is going to be skewed left. And the mode, so we both have one peak, so we're going to say that they are both unimodal. All right, so for 7 to 12, the population of 15 rural towns in Georgia and 15 rural towns in Alabama are organized and displayed in these box and whiskers. Now, we may be able to do some more analysis of spread here with the box and whiskers because we know where our maximum is, we know where our minimum is. We can do a little bit more estimation here. Now, it says, which state's data set has a greater center? So I'm assuming here that we're going to be talking about, for the center, we're going to be talking about the median. And the reason we're going to be talking about the median is because we can't determine the mean from a box and whisker plot. So this one has a median at 20. And Alabama has a median at 25. So Alabama has a greater center. All right, how does the shape compare? So remember we talked about shape. So I would say that Alabama, if we kind of look at that way it's spread out, for that lower half, we have basically from 5 to 25, so that's 20. Then we have from 25 to 45, so that's 22. So I would say that Alabama is very much symmetric. All right, so then if we look at Georgia, so if we go from roughly, it looks like maybe 2 to 20, we would say 18 in the lower half. And then 20 to 35, we would say about 15. So there's more grouped in the Georgia area because there's less spread. So this one is showing me here that the tail is going to be on the longer section. So this is my tail. So therefore this one's going to be skewed to the left. So this one, how do the shapes compare? Again, we would say Georgia is skewed left, and we would say that Alabama is symmetric. Now, do these have an outlier? Now, the only way that we can have an outlier, okay, is if I have skewed data. If I'm having it skewed to the left or skewed to the right. Does either data set have an outlier? So, not always, but most of the time when you're talking about skewed data, you're talking about an outlier in that situation. So if I'm looking at skewed data, I potentially have a value. Now I'm going to clear some of this out so that we can see what I'm discussing here. I have a value that sits over here away from the rest. So the rest is kind of grouped mostly between that kind of 10 to 35 area, and then I have this minimum down here that sits at about 2. So I would say that is an outlier. That does not fit in with the rest of the data. So I would say that it's in thousands. So I would say the outlier is approximately 2,000 in Georgia. Which state has a larger spread? So here we go. Now we can actually calculate the spread. We can do the range here. So my range is my maximum. My maximum is 35 minus my minimum is 2. So this is spread out by 33 units. My range for Alabama, I have 45 minus 5. So that one's spread out by 40 units. So which one has a larger spread? The one that has a larger spread is going to be Alabama. So true or false? The 15 rural towns in Georgia are mostly between 15,000 and 30,000. So it's saying that most of my towns, if I have 15 towns, they fall in between 15,000 and 30,000. Now, that statement is a false statement because it says mostly between there. Well, that can't be true because if this is 50%, because remember each section is worth 25, this is also 25 here, and this is 25. So it's actually pretty even as far as the distribution. And then which data set has the smaller range? Well, we already figured out that Georgia has the smaller range. So if we're talking about shape, shape is going to be symmetric, skewed left, skewed right. Center is going to be mean or median. And spread is going to be most of the time talking about your range. How spread out is your maximum versus your minimum.